more nuance that sometimes happens when we do integration by parts. Sometimes it looks like we're just going in circles. Let me do an example of this to illustrate what I mean. So let's say I ask you to evaluate the integral of e to the 3x times cosine x dx. So something times something, we certainly can think about using integration by parts here. And if we take a look at our chart here, so what do we see here? Trig and exponential functions. So we have an exponential function e to the 3x. We have a trig function cosine x. So, oh man, there's a trigonometric. Bad typo. My apologies. Trigonometric functions. Okay, this is what we want to use for our u here. So let's try this out. So we're going to make the choice here that u is equal to cosine x, and then this is going to be our dv right here. So let's try this on. Let's see what happens. Okay, so u is equal to cosine x. dv is equal to e to the 3x dx. Du is going to be, take the derivative of cosine x, we get minus sine x dx. And v is going to be, when we integrate e to the 3x, we get 1/3 e to the 3x. And so we now say that the integral of e to the 3x times cosine x dx is equal to u times v, so that's 1/3 cosine x times e to the 3x minus the integral of v du. So minus 1/3 e to the 3x times minus sine x dx. I'm just going to recopy this line and move that 1/3 and that minus sign out in front. And so now we have e to the 3x times sine x dx. Okay, so the premise of doing integration by parts is that this integral should be simpler to do than this integral. And at this stage, it doesn't really look like we're delivering on that promise, right? You know, we've got cosine x, e to the 3x times cosine x here, e to the 3x times sine x here. That feels just about the same level of difficulty. I hope you agree with me on that. But let's just proceed. Let's just keep following our nose here. Let's say, I'm just going to split that off as its own separate problem. Let's say that now we have to do the integral of e to the 3x times sine x dx. Once again, our chart says that trigonometric functions, so sine x is of higher priority than exponential functions. So u will be sine x, and dv will be e to the 3x dx. du would be cosine x, and v would be 1/3 e to the 3x dx. So this is equal to uv, 1/3 sine x e to the 3x. Oops. There should not be a dx there. v is just 1/3 e to the 3x. Minus the integral of v times du. There should be a dx there. My apologies for the mistakes. And so now let's put together this equation and this equation. So what are we concluding right now? We're concluding that the integral of e to the 3x cosine x dx is equal to 1/3 cosine x e to the 3x. So what I'm doing right now, so I just copy the integral of e to the 3x cosine x dx is equal to 1/3 cosine x e to the 3x. And then it's going to be plus 1/3, plus that 1/3 there, times this integral, which is 1/3 sine x e to the 3x minus the integral of 1/3 e to the 3x cosine x dx. Now take a look at all of this here. Take a look at all of this, and let me make one more change. Let me expand. Let me just kind of rewrite this. 1/3 cosine x e to the 3x plus 1/3 times 1/3 is 1/9 sine x e to the 3x minus 1/9. I'm moving that 1/3 times 1/3. I'm moving that outside. The integral of e to the 3x cosine x dx. Okay, so let's take stock of where we are. Again, but from everything that we've done so far, says that this integral is what we're looking for to be simpler than it was before. But do you notice anything? This integral is actually the exact same integral as what we started with. So this is why I titled this example here, Going in Circles. Feels like that we're just going in circles, we're looping around, we're not making any progress. That's what it feels like that we're doing here. However, there's one trick here for us to use, which is we can actually algebraically solve for the integral that we care about right now. So the way that I like to do this is I like to say that, call this integral I. I is the thing that we're looking for. And so then this integral that appears on the right-hand side is also I. And so what do we have? We have that I is equal to 1/3 cosine x e to the 3x plus 1/9 sine x e to the 3x minus 1/9 times I. And at this point, it's just a simple calculation for us to, we're thinking I here is a variable to solve for. We move the terms of I to one side, and then we divide by the appropriate coefficient, and we're done. So we move the 1/9 I to the other side, and so that gives us 10/9 times I is equal to 1/3 cosine x e to the 3x plus 1/9 sine x e to the 3x. And so what do we conclude? I, which is the integral we care about, is 9/10 times all of this. Now there's one little thing I have to do here. At this step, there are indefinite integrals on both sides of our equation. Here there's only an indefinite integral on the left, so we do have to put in our plus c at this point. So this is how we tackle this kind of problem. Let's recap what's going on here. So whenever you have, and this is a very typical problem, whenever you have the integral of a product of an exponential function, a trig function like this, it is pretty typical that we, quote unquote, let me wave around my fingers like air quotes, and we go in circles. And so the way to tackle is that you just set u to be the trig function in each case, and you apply integration by parts once here, and then you have a second time to apply integration by parts. And so let me get that slide, bring that slide back. And so applying integration by parts here gives you this, and now you take this part and substitute it back in for here, and that gives you this equation. Now, after expanding things, what you have to do is you realize that you have the original integral is on both sides here. And so now you just set up a simple equation involving I and then solve for it. So that's how you tackle this kind of problem. And I think that this is an important type of problem. So here's a second pre-class problem for you to do. I want you to practice this quote-unquote going in circles kind of thing to tackle this integral.